Thanks for joining. We are inside day number 7, and today we are going to learn one very important topic we have in SD-WAN, Cisco SD-WAN, is TLOC, Transport Locator. We have labs related to TLOC in the upcoming section, in the policy section. So we will understand more and more about the feature related to TLOC. Now, in very loose term, if you want to understand TLOC, is nothing but you can think this as a BGP next hop type of maybe address or type of attribute. Okay, so it is something like next hop attribute, and how it is applicable and what are the capabilities we have and what are the building blocks we have related to TLOC, we will go and check. All right, so let's start. First of all, we'll study about TLOC today, and in upcoming day, we'll go and learn about the OMP. Now, before going to the terminologies and the attributes we have inside the TLOC, I just wanted to see one diagram here. And from this diagram, we'll try to understand first of all about the TLOC. And then we'll go back and check the attributes of TLOC and what are the other things we have in the TLOCs. Okay, so let's try to understand this particular diagram here. Let's try to think that how this SD-WAN is working. And not only SD-WAN, whatever fabric we have, their tendency, their nature is almost the same. Like if you go and check the fabric is nothing but the virtual network. So if you go and check the fabric, that means that you have one fixed hardware. On fixed hardware, on top of that, you can go and run services. So for example, cloud services. Different cloud providers are there. As a user, whatever service we want, we are subscribing only those services. But again, it's a loose analogy. In SD-WAN, you may have your router, switches, everything connected. If I have any lab topology. So again, the same diagram. Oh yeah, so here you can see that suppose if we have this type of topology or any type of complex topology, where you can see some routers, some switches. So you may think that what's the new? Same we have in the WAN and same we have here as well, right? But the answer is no. When you go and learn the services within this SD-WAN, you'll find that it's not exactly same, although the underlay, although the connectivity within the hardware, that is the same. So whatever connectivities we have in the hardware, and let me try to draw with some other tool. So okay, so whatever connectivity we have here from the edge device to the other device, device to device, device to device, isn't the same we have in the existing WAN as well? The answer is yes, it is there, but this is just one snapshot of the services. It's just one instance of the service. It's not full service. That means over this instance, I can go and create VPN 10. Over this service, suppose we have something called VPN 10. So the behavior of VPN 10 is different. Again, I can go and create one other instance of service that will be VPN 20. So I can go and create a VPN 20 as well. So I can go and create VPN 20. If I can change the color, so VPN 20 with green, I can go and create VPN 20. Then I can go and create 30, 40, whatever, n number of VPNs. Now the nature of those VPN, that may be this particular VPN that we have, that is nothing but VPN 10, they have this type of IPsec tunnel, point-to-point IPsec tunnel. This VPN 10 maybe they are full mesh, but VPN 20 maybe partial mesh, maybe hub and spoke, maybe only one branch to other branch. So we have the control mechanism that we can go and control not only the control plane, but we can go and control limit the data plane tunnels as well. That control is something you can think as a fabric services. You have full-fledged underlay hardware, data cables are connected, everything is connected. But the way we are flowing the traffic from one location to other location, it's 100% different. So who is going to provide you those capabilities that we are going to discuss today? So there are two major players here. One is TLOC, Transport Locator. Other one is OMP, Overlay Management Protocol. Okay, although OMP we will learn in the next class, next hour. But today we'll try to understand this TLOC. What is TLOC, how it is working, etc. Okay, so as I told you that TLOC is nothing but the next hop type of BGP attribute, or you can think that BGP next hop is there. So TLOC is the next hop type of attribute. How it is? So try to understand this diagram. Now let's focus on this particular diagram. You can see that we have diagram here. You think that this is one of the V-Edge device. So this is one V-Edge device. And in this V-Edge, we know that we may have VPN 0 interface, we may have service interfaces. So suppose it has one service interface, you can see VPN 1, and then it has transport VPN, that is VPN 0. So you can see the color here, blue and red. For example, this VPN 0 is nothing but the WAN facing interface, and VPN 1 is nothing but where you have your catalyst switch connected, where you have your LAN, or maybe you are running other OSPF underlay, BGP underlay, etc., etc. Okay, so you have VPN 1, and then you have VPN 0, right? And this box that you are seeing, within the box, it's one unit. Within the box, you can see VPN 0. Within the box, you can see VPN 1. Now think that how this box will get connected to the ISP. So suppose if this VS device having 3 ISP connection, ISP 1 is internet, here internet MPLS 4G, like that you can think. ISP 1, ISP 2, ISP 3, like that. So all these interfaces will be part of what? All these interfaces will be part of VPN 0, right? And then you have something in your LAN interface, maybe you have one prefix called A that you want to send to other side over the WAN to reach prefix B. So A wants to reach B, B wants to reach A. These are the prefixes, and they are inside VPN 1. This side VPN 1, other side VPN 1. So far, any doubt? It's easy, right? So how this prefix A, which is part of VPN 1, will go first of all to VPN 0, and then from VPN 0, how it will go and reach out to other side VPN 0, and from that VPN 0 it will reach to VPN 1, and from that VPN 1 it will go to VPN B. How this reachability will happen? Because as we know that from VPN 0, so VPN 0, you should have some interfaces. You can see that suppose if you have 3 interfaces, say gig 1, gig 2, gig 3. Suppose this is gig 1, this is gig 2, gig 3. This belongs to the three different ISP, but we know that over VPN 0, we have data plane tunnel. We have data plane IPsec tunnel. So that means that in between here to here, we have IPsec tunnel over internet, over MPLS, over 4G, right? So that means that prefix A will reach to VPN 0. Maybe we have some static route underpinning like uh, suppose this is say ETH1, for example. ETH1 is pointing towards VPN 0. Like that, we have a static route within the fabric. Like that, you can think. So somehow the VPN prefixes, they know that how to reach to VPN 0 internally. Now from VPN 0 to other VPN 0, we have IPsec tunnel, point to point IPsec tunnel. And with that IPsec tunnel, obviously, whatever source A having, it can go and reach to the destination B, or B can come and reach to A. Like that, it is happening here. It will be happen. But behind the scene, then what is the role of VSmart here? What's the role of OMP here? What's the role of TLOC here? That we need to understand. Slowly, we'll try to understand this. So let's break this particular route advertisement into two parts. Let's focus on the half portion. Let's try to understand this section first, this part. Okay, so now you see that you have prefix and then you have your VPN 0, and over VPN 0 you have something called IP address. For sake of simplicity, I'll tell you the IP. Sometimes it will be public IP. How you are forming the IPsec tunnel? You can form the IPsec tunnel as long as you know that what is the tunnel endpoint address. Means if you know that what's the IP address here and what's the IP address here, if these devices know their end host IP addresses or end gateway IP address, then that's the first criteria. The second criteria I told you earlier, that VSmart is working as a key server. So they know their key, different type of keys. So they know that key via VSmart. VSmart is sending the key. So then they can go and form the IPsec tunnel, but still one piece is missing here, and that part is nothing but the TLOC. So the IP address that I am writing here, IP public, right? This IP public, now in SD-WAN term, you will think that this is nothing but the next hop type of address with attributes, and that nothing but the transport locator. As name suggests, transport VPN is what? VPN 0. So whoever is going to locate the VPN 0 in the fabric, its name is transport locator. It's its duty to locate that particular next hop VPN 0 IP address to the other end host devices. Basically, its duty to give this information to the VSmart. VSmart is someone who is, so VSmart, what it is doing, that they are encapsulating this TLOC within OMP. Later on, I will show you in day number 2 that OMP protocol, overlay management protocol, they have 3 different type of routes. One of the route is TLOC routes. Okay, so somehow the TLOC information is reaching to VSmart. You know the communication in between VSmart and VH? What's the communication protocol? OMP. OMP is running in between VSmart and VH. By default, it is on, right? So with help of OMP, the VSmart knows that what's the TLOC. Okay, so now it will be a little bit easier to understand. So if I have one prefix A here, VSmart will learn prefix A, right? But VSmart, how VSmart will come to know that this prefix A is coming via internet or MPLS or 4G? So for that very reason, what we are doing, that if you go and check, we are going to VPN 0 interface. Over VPN 0, we are going to some interface, like for example, interface Gigi 0. Then we are going to tunnel interface. And then we are defining the color. Say color may be blue, red, green, or maybe sometimes color may be MPLS, or maybe sometimes color is internet or business internet, etc. Right? Sorry, internet. So here you can see in the diagram as well, if you see little close, orange and greenish and blue type of three color is there. These colors are not exactly MPLS. We are telling that, okay, in my fabric, I am telling that internet color is blue or green. In my fabric, I am telling that MPLS is color is name is MPLS. We are marking it. So if prefix A is there, this A may have three next hop. So the next hop may be orange, and they are represented by some color, orange, MPLS, and maybe blue. Like that you can think. So when the prefix information of VH, for example, this is VH1, it will reach to VSmart. How VSmart will come to know, oh, orange, that means it is coming via internet. Oh, MPLS, that is coming via MPLS color or MPLS circuit. Blue, that means it is a 4G circuit, right? But these are nothing but the next hop. These are nothing but the transport locator. So in other words, the transport locator, TLOC, they have attributes. Actually, they have so many attributes, but they have three major attributes. Let me write like this: system IP, color, and encapsulation. Now here, if you see for prefix A, that I'm telling that we have, I hope you are able to see the font is small. It's okay, right?
The font is fine. I can see it.
Okay.
Font is fine.
Try to little bit increase. So, hi. So what I'm telling here is this, that the A having three next hop. These three next hop are nothing, aka TLOC, and this TLOC. So if you go and define this A TLOC, so number one is system IP. For example, this V is having system IP 111. Then other one is color. For example, let's take the color that we have taken earlier. What's the color? Orange. For example, orange is for internet, think like that. And then encapsulation is IPsec. Now next time, this second hop also system IP will not change. Then MPLS, then IPsec. Then the third hop is 111. Then the base internet, and then the IPsec. Now you will see here, and that's the key and catch. System IP and IPsec common. Now suppose VSmart will get these information. So how VS Smart, suppose if I go and write orange, orange, all these three places. So here also and here also. Then how VS Smart will understand that all these update that I am getting via three different next hop, they are different. So color is one type of differentiator we have. So VS Smart will come to know that one is coming from internet, one is coming from MPLS, one is coming from 4G, etc. This is blue actually, written blue there. So this is internet, this is MPLS, this is 4G. So color is one of the very important attribute we have for TLOC. All three are attribute of TLOC, although there are other attributes as well, but these are the major attributes. Okay, so now VS Smart come to know how they come to know. They come to know via the OMP protocol with help of TLOCs or OMP TLOCs, that to reach to A, I can reach to A via TLOC 1, TLOC 2, TLOC 3. It is there in the diagram. You can see registration update TLOC 1, 2, 3. Likewise, B will also send, right? Because VS Smart, how it is working? We know that VS Smart is working as a route reflector. VS Smart will go and learn everything within the fabric, within the SD-WAN fabric. And then what VS Smart will do, it is working as a route reflector. So it will go and reflect B in this direction. It will go reflect A in this direction. So he will understand A and he will understand B. Okay. Now again, when this particular edge device will receive A subnet, so B will go and meet A, then V edge, he should also understand that how A is coming. So again, this A, whatever prefix that we have A, it is attached with three different TLOC. So now the suppose this is 2 and this is 1. So 2 will understand that I am receiving A with this TLOC. I am receiving A with this TLOC, with this TLOC, and vice versa. Now that's the importance we have with the TLOC. TLOC is type of a differentiator. It's a next hop attribute clearly, but it will, so VS Smart, whenever they receive the route, he will distinguish that it is coming via this color, this color, this color, or this ISP, this ISP, this ISP with help of TLOC. That is one of the use. Apart from that, there is other use as well. When we will go and study about the policies, about the control policies, in that you will come to know. So I'll give you an example. This is just an example. When you watch the recording, you can check this logic. Later on, we have the lab with this particular logic, exact logic we are going to use. Just for the sake of simplicity, suppose I have one DC, suppose DC you have, and you have branch 1 and you have branch 2. Obviously, your VS Smart is there somewhere, and all the devices they have some sort of control connection with VS Smart, and all the devices they have IPsec tunnel. So this blue color is IPsec tunnel. Okay. Now tomorrow what will happen, that organization, it will tell that okay, from branch to branch we don't want any tunnel. We want that all the tunnels, all the communication should reach to data center first, because in data center I have firewall. So all the traffic will come to the firewall, will come to the sensor, and then it will go to anywhere. That means you don't need this tunnel anymore. And then you have to make the IPsec tunnel only with the DC. This is something called hub and spoke type of a structure, HNS, right? So in that, what you will do, suppose you have 200 branches. What you will do, you will go to all the 200 routers, branches routers, and do the IPsec changes and do some next hop changes and all, right? It's very tedious. And suppose tomorrow, if suppose if you have DC1 and suppose you have DC2, and then if organization will tell you, okay, 50% of branches will think that DC1 is the primary, 50% branches will think as a DC2 as a primary. What you will do? It's very difficult in existing WAN to make such type of changes, traffic changes within maybe within a day, within an hour, right? These things can be achieved with few small rules in SD-WAN. So I'll give you the first example, that is that you want to send the traffic via the data center. What you need to do, so they are sending their TLOC, right? Everyone is sending their TLOC to VSmart. How these two branches, they are forming the IPsec tunnel? If somehow he will not receive the TLOC in this direction, he will not receive the TLOC in this direction. So what you need to do, simply just create 3-4 line rule in VSmart. VSmart you tell, okay, receive the TLOC from branch 1, and when branch 1 will send the TLOC to branch 2, just block it or reject it. Receive the branch 2 TLOC, and when you are sending to branch 1, just block it. That means you can do the control from the VSmart level. We have lab related to this later on. I'll show you that. By default, we have full mesh tunnel with respect of this small change, a small policy. At the moment you start blocking the TLOC, so this device will not learn the TLOC from the branch 2, and this will not learn the TLOC from branch 1. That means their IPsec will not form. Obviously, you don't know the next hop, how you will form the IPsec tunnel, right? So that's the power we have. Without knowing the TLOC, these devices, they will not form the IPsec tunnel. They will not, even VSmart will not know what's the next hop for this particular prefix. And with help of TLOC, we have so many different tunings that we can do. It will be there in best path selection criteria. It will be there in forming the IPsec tunnel. It will be there to advertise the routes and all. So TLOC is one of the important thing we have in the SD-WAN. Right? You have any question?
No questions.
Great. So let's quickly go and check the TLOC and few of the examples. We have some slides here. Okay, some of the term transport locator, you can think this as a next hop route attribute. Color, as I already told you, this is some sort of tag. It's nothing to do with anything. It's just a logical thing. This is a tag value. We know about site ID, we know about system IP, we know about organization name, we know about the VPN. Great. What is OMP? And here in the diagram, you can see clearly that OMP is forming within the VSmart and in between VSmart and VEdge. OMP is not forming within the VEdge to VEdge. Okay. So that's the important information we have. Then we know about the VPN and zones. We know that we have VPN 0, and you can see this is untrusted zone because it is exposed to the public, because this is public facing interface. Then you have VPNs, then you have management VPN. So these things we know. Then we have discussed about this. Later on in the OMP, I'll come back one more time and we'll discuss about OMP as well in this. You can see the underlay where you have the TLOC and the overlay where you have the OMP. Few diagrams here just to give you more information about the attributes of TLOC, system IP, color and encapsulation. They are the attributes of TLOC, although there are more. And this is just a logical diagram that by default these devices, they are forming full mesh connectivity. But if you want with with help of TLOCs, we can control this. We can make this hub and spoke or a spoke and a spoke, etc. One more important thing here, that in some session earlier, I told you that when you are defining the VPN0 color, at that time you have something called a restrict keyword as well. Restrict. That means that by default you can see this yellow and green. So by default you can see that green can form IPsec with green, yellow with yellow, green and yellow. This is the default nature. But if you go and use the restrict keyword, then this will not happen. Then while the same colors, they will go and form the IPsec tunnel. Okay, so it's actually in terms of transport locators. Same color transport locators, they are forming the tunnels if we are using the restrict keyword. Right? Again, same thing here, that if you are using the restrict keyword, so they will not form the cross color tunnels. Again, some colors are private, some colors are public. Generally you can see the list of private and public color, and we should pay attention by while creating our tunnel. Generally in normal standard practices, MPLS we are making as a restrict. We don't want that MPLS will go and try to form the tunnel with the public colors. So private should form tunnel within private tag or color tag, and public will go and form within the public tag. Then there is one example here. It is not that much visible, this complete diagram, but it is telling that if you have this device here, so if you go and write the TLOC for this device, what will be the TLOC? So first of all, what is the system IP of this? Suppose the system IP of this device is 10 dot, for example, 3.0.1. So its TLOC will be system IP color. This green is what? Maybe this is MPLS. So for example, MPLS, and then IPsec. Same thing here in the node. The system IP is this. The TLOC will be system IP, color, and the encapsulation. Here it is for this particular example. It's like that. If it has two interface, then it has two different colors, right? Two different TLOCs. Two interfaces, two different TLOCs. What will be that? It's very easy. Suppose if this is MPLS, this is internet, right? So it will be 10.4.0.1 MPLS and then IPsec, and then 10.4.0.1 internet plus IPsec, right? Any doubts so far? So if I ask you that what is TLOC and what's the significance of TLOC, you can answer me. Yeah, question to you. What is TLOC, transport locator?
It acts as the next hop.
So acts as a next hop, 100% right. And what are the three major attributes of TLOC?
System, IP,
color and
the
encapsulation.
color and encapsulation.
System IP, color and encapsulation, right? And who will receive this information? Who will get the TLOC information?
vSmart.
vSmart is getting. Now, if you go and check this system IP, suppose 10.4.0.1, we know that system IP is not a routable thing, right? It's not a routable IP. So color and encapsulation, those are very much like sticking with the device, correct? System IP is something which is not routable. The IP that we are providing over the interfaces, they may be routable, or the LAN interfaces, they may be routable. But the IP that we are putting over the box, to the box, that's the system IP, is not a routable IP, right? So these are very important things to understand this nature of the fabric. Great. So we understood most of the things related to TLOCs. I'll later on I'll explain about this complexity. Right. And OMP also. We have one full session for OMP. I'll explain you about OMP as well. But before reaching there, just one example, one use case example I'll give you. So suppose I have one device here in one of the branch. This is branch 1. It has one interface. Obviously, it is part of VPN 0 going towards the WAN. And then it has one LAN interface, say VPN 10. Okay. And here in LAN interface, I'm running in this section, I'm running, for example, I'm running OSPF. Okay. And I have branch 2 here. In this branch 1, you have something called, there is one network. Suppose network is A. Now, my question to you is this, that how A will reach here? You got the entire question?
Redistribution to OMP and back.
Yeah, that's right. So how it will happen? Logically, how it will happen? Somehow, so we can think like this. So this portion that we have, right? By default, here you have OMP. So that means that inside VPN 0, whatever network information you have, it is reaching to VSmart via OMP protocol, right? Because this is something OMP TLOC, because this is nothing but the next hop, right? Now the question here is this, that you told you told right that somehow this OSPF has to go inside OMP. So now you can think that how simplified this SD-WAN fabric is. Now if you want to send anything here, you don't think that you have to send anything to branch 2. You just think that you have to send to VSmart. If you are successful to send any prefix information to VSmart, VSmart will automatically send to anywhere by default, right? So if OSPF somehow will reach, or the OSPF network that we have, it somehow will get injected inside OMP, because they are knowing, because they are OMP peers, the VSmart and VEdge, right? So if OMP will know, that means VSmart will know. If VSmart will know, that means other branches will come to know, right? So that means OMP, if he knows, he will tell okay, then it will reach to VSmart. If VSmart tell okay, because it is the route reflector, so he will immediately go and reflect to other places. That means here that OSPF need to be advertised inside the OMP. Your answer is right. Like we, as a Cisco engineer, we know that redistribute command is there. It's there. But if you go and check OMP, within OMP we have something called advertise. Redistribute, advertise in SD-WAN both will work together, but in normal Cisco world we have only redistribute. So you can go to BGP, redistribute OSPF. You can go to OSPF, redistribute BGP, right? But here, anything that you want to send from OMP, you have to go OMP and then advertise. Still, you can go to OSPF. Okay, I will not make this complicated. Till this point, you have any doubt, you please ask.
No, I'm good. I understand.
No, I'm good.
Okay, so this is just 35 minutes that I started the class. If you're watching this video, you come to this point because I'm going to ask you the second part of this question. Let me erase and ask. Okay, let me draw. The second part of question is this: same branch, and you have ISP, and you have branch 2, and here you have OSPF. Okay, now here you have something called B2. Now this B2 you want to send inside the OSPF. How it will come? Very easy, right? It should reach to VSmart via OMP somehow. Now I change the color, right? No problem. Now this is working as a route reflector, so it will go and teach to the VPN 0 this interface up to here. We know that up to here we have OMP, but still next what you need to do, you have to go inside OSPF, for example OSPF1, and now you have to do redistribute OMP. That means now you are injecting OMP within the OSPF. If you watch the recording, you'll find I told that go to OMP and advertise OSPF. Here we are going to OSPF and redistributing the OMP. One place you are using keyword called advertise. This place we are using the keyword called redistribute. So be careful. When you are going inside OMP, you have option to advertise static, connected, other protocols. When you are going to OSPF or BGP or EIGRP, you have to redistribute. Okay. Now in all the cases, the next hop always will be your TLOCs. That means system IP, color, and encapsulation. Okay. Good. Let's move on. Securing the data plane. This diagram, you can see how complicated this is, but this I have explained at least 3 times. So when these devices, they are forming the IPsec tunnel, suppose these are the IPsec tunnel, inside that we have BFDs. Later on, I'll go and explain about the bidirectional forward detection. BFDs we have. The moment IPsec tunnel is up and running, BFD will start running. So we know this thing that they are sending their TLOCs. OMP update is nothing but within that you have the TLOC information, and VSmart will go and give you the key information because it is working as a key server. So now he knows that what is the next hop IP. Now he knows that what is the key, what is, you can think as a next hop key. So what is the key from the remote side, and then they will go and form the IPsec tunnel. Only with help of VSmart and OMP it is happening. Okay. Again, you can see the key thing is coming. So yes, within the OMP update, you have the encryption and decryption keys, and like that they are exchanging. No need to go too much detail inside that. It is happening within the fabric automatically, and VSmart is playing the role as a key server to exchange these keys to form this. We don't have to do anything. Everything is optimized behind the scene. Yeah, if we don't want that this tunnel should form, this tunnel should go and form with the data center, and all those things we can manipulate. This is the default nature. And that's the same thing, data integrity and all those slides are there. That is just for the reference. So if you want this breakup type of tunnel, it's there. We can go and do the segmentation. All those capabilities are there. More we'll go and check in our lab as well. Now you can see that over the VPN 0, you have multiple VPNs, VPN 1, VPN 2, VPN 3. This is called segmentation. Although it is not clear in this diagram, but what exact segmentation is exactly is that you have VPN 10, suppose 10, 20, 30. For VPN 10, it may be full mesh. For VPN 20, it may be like this. VPN 30, it may be local breakout, directly going to internet. That's the segmentation we have. Two segmentation we have within the fabric. Within the same, see, all these interfaces are over VPN 0. Either it's the VPN 10 or 20 or 30 that is doing some local exit, etc. for guest traffic. Everything is over VPN 0, but because it's a segmented, it's actually VRF aware. So you can think as over same interface, you have multiple sub interfaces where you're defining different VPN tag or VRF tag, and then traffic is segregating. That's the same thing here. Same VPN 0, this may be for employee, this may be for guest, right? Like that you can segregate. Great. So we have covered this TLOC, and obviously we have lab related to TLOC in the upcoming session. The next very important topic we have is related to overlay management protocol. So what I will do here, I will show you this overlay management protocol. There are three types. You can see here three types: OMP route, service route, transport locators route. I'll explain you that, but again in the next class we will understand more and more about that, and I'll log into the device as well, and I will show you that how you can go and check OMP peer, how you can shoot, how you can go and see TLOC routes, how you can go and check the control plane, data plane, tunnels, everything I will show you from the CLI as well, that you can verify. But before ending the class today, what we will do in this diagram, I'll explain you all different type of routes we have in the fabric, and it is actually very easy. You will understand. Yeah, any question?
Yes, I have a question. I've seen in certain deployments that they'll apply a TLOC to a loopback. Why is that?
Okay, that's good question. So sometimes it is happening. Here you can see in this diagram that you have this MPLS. So to reach out to the controllers, generally you will find that controllers, they are hosting over the public cloud, right? And suppose if this device having only one connection going towards the private network, so in that case, how you can go and extend the control from the private to the public network. For that, we are using this loopback 0 to create the TLOC to extend or to do some sort of communication between the private and public. Now, what you can, I have certain examples related to that. What you do that when we'll start the policy, maybe after 3-4 classes, I'll come back and I'll show you with example when we'll do the configuration and all. So I will show this where we are creating the loopback, how we are extending the control connection, okay, within the private, and what's the use case.
Okay, excellent.
Okay, so just wait for 3-4 classes and then we will see that.
Sounds good. Thank you.
Yeah, and let's see this diagram. So we are here in this diagram and you will see, okay, this is full-fledged SD-WAN. You think that what type of routes you have. We know that we have something called service-side VPN, right? Service-side VPN is this, that if I highlight this in red, anything that is not VPN 0, VPN 512, those are nothing but service-side VPN, right? So initially, when Viptela has created their SD-WAN, so at that time, they are telling this service-side VPN routes are nothing but the Viptela routes. So here you can see this V routes. They are nothing but the service-side VPN routes, V routes. Sometimes it is referred as a OMP routes as well. Okay, so V routes are nothing but the OMP routes, but they are non-VPN 0, non-VPN 512 routes, right? All right. Then next you can see in the diagram your next hop routes, that is nothing but the TLOC routes. And I should use some other color for that. So let me use this blue color. So here you can see this TLOCs. Okay, so that means OMP has two different type of routes. One is either Viptela routes or service-side VPN routes or OMP routes. Other one is nothing but the TLOC routes, right? TLOC routes, correct? Any doubt in this? Nothing, right? So if I color all these things, you can see that is still there is one more route left, which is nothing but your services like firewall, VPN, other gateways, those routes. Yes, so we have third category as well. That is nothing but the service routes. These are nothing but your firewall location routes. This is a firewall location IP. So vSmart knows that what's the location of firewall within the fabric. These are the location routes, locator routes for firewall. So vSmart knows in a fabric where is the firewall, because tomorrow if we have to go and create policy, something called service side redirection or redirecting the traffic towards the services, or you have to do some traffic engineering that the branch traffic will go to the firewall and then go through the internet, right? Or it will go to the firewall and then it will go to any other branch. And these policies, from where you will create, you have to go and create from the vSmart, right? So that means that vSmart should know the location of firewall as well. Otherwise, you can't create such type of policies, correct? So that's why we have these three different type of routes. There are more and more to OMP. That what is OMP, best path selection and all. OMP is lightweight BGP. It has so many attributes that we have in BGP. So we'll learn more and more about OMP in the upcoming class. Meanwhile, if you have any other question, you can ask.